I'm Rishikesh. Hi, I'm Dhananjay.
And hi, I'm Surbi. Today we are launching Melon, a platform that helps segregate IRL content from AI generated content using cryptographic proofs and trusted hardware sources. Let me walk you through the demo.
Let's get started. So the idea here is to have trusted sources of hardware on which our firmware layer sits, and it embeds cryptographic proof within the EXIF format. So EXIF formats are the formats that are generated that are as given as output by the camera module itself, and we embed a cryptographic proof inside it before it is converted to JPEG, PNG formats. So I'll just walk you through what we've built here. So first, if you have a hardware, if you own a hardware like we do, we have a Raspberry Pi for now. You can just come on this platform, connect your wallet, and basically add your device ID. So what is this device ID? Device ID is the hardware UID for your particular hardware that you have. And for now, what I'll do is just run this generate uid.sh, which is already available on our source code. And this would get us the hardware UID for this particular Raspberry Pi, as you can see in the camera. So I'll just copy this hardware UID, which is a unique hardware UID just for your machine. And then I'll paste this and I'll do stake to whitelist. So if you haven't already staked, you should definitely stake and be a trusted source of verifier. And you can see I've taken 0.01 ETH for now, and let us wait for it to process. By the time it's happening, we also whitelist this particular wallet address and map it to this device ID so that we can query and have efficient lookups for this particular user and this particular hardware in general. So once the stake is done, what you can do is go back again and you can like use this camera to click any pictures. So for example, I'll just run a script again to uh, run take a image of myself that is not AI generated, but it is coming from hardware. So source now, which is the Raspberry Pi clicking my image. So I would capture the image and embed it with our digital signature. For you can see, I'll just click and yeah, should I really take my photo and also verify it for the first time? So let's see if it verifies my proof. And you can see the verification result was successful. Now I'll just run a simple fetch script that would fetch the image locally because it is an SSH setup for now. So I've SSH it onto my Raspberry Pi. So now I have the image locally. That's good. So let me just verify it and try to see if it's authentic. I'll just go to where the actual file script is. So this was the capture with proof image. As you can see, it's not looking very good, but yeah, it's authentic. I could say that by just verifying the proof here. So this would verify the actual image bytes and not the JPEG content. It actually looks into the EXIF format. So what EXIF format is EXIF is a format which is outputted by the camera output itself. And us being at the core of the OS layer and in between the hardware, we are easily able to track it down, and we have a hardware based private and public signature using ED25519, and then using the private key we sign the cryptographic payload, and then we also embed the public key into that, and then we verify it on the other side using the same public key. As you can see, the data has been stored on OG storage, and we've also have verified our device that it is from a hardware device. And what was the hardware device? The device ID was by CL01. What was the firmware? What was the signature algorithm that was used? The image hash and the digital signatures and all of that cryptographic stuff. So the main goal is here to verify your entire photos that you take from a trusted source, which is our Raspberry Pi camera for now. So how would you